This week's DMT Insight is on how bar models help students see the structure of math to solve word problems. That might sound boring, but I can tell you one of the top 5 things in education is why do my kids struggle with word problems all the time? Even if they can add, subtract, use algorithms, multiply, divide, they still struggle with word problems. And so it's about the structure. So bar models are so powerful for 3 reasons. 1, they make the structure visible. They build schema, deep understanding of the mathematics, and then they allow for transfer of information. That's what we want in education. That's what Singapore found out in the 1980s. Same thing happened. Kids were not doing great in mathematics, especially with word problems, and they came up with this idea of a rectangle to focus on quantity, which then enabled them to the kids to understand the mathematics, and then their scores through the 90s skyrocketed. So let's start with a word problem. So Maria has 47 stickers and her brother gives her 25 more stickers. How many stickers does she have? Great, a lot of kids jump in, they see the 2 numbers, 47, 25, they add them and they get the answer 72. Let's just change this a tad. We're changing the structure. Maria has some stickers. Her brother gives her 25 more. She now has 72. How many did she have to begin with? What do you have here? What students do, you take the 25, the 72, they see those numbers in the problem, they put them together, they add them, they get the answer wrong. So a third one, Maria has 47 stickers. Her brother has 25 stickers. How many more stickers does Maria have than her brother? Let's just add those 2 numbers together, you get a total. This happens all the time, especially because they hear the word more, so that means add, and they put it together, and of course, it was supposed to be 47 minus 25 is 22. It's a subtraction problem. So on 2 of the 3 problems, kids are getting those wrong every time because they don't understand the structure. So what do we do here? We're going to introduce the bar model, the rectangle, and it's very specific on how we're using the rectangle. We want to have it be proportional, and there's certain ways of connecting it where we're creating area at the same time. Those are critical. And we'll have some examples that you can see in our teacher document at the end. So the first one, here's the bar model. We have the quantity of 47 that we're focusing on, and then in addition to it, we're adding on, so we're going to connect it, the 25, because she's getting more stickers, and then on top, we're going to show that's where the question mark is, the entire total. So then you have the structure of like, yep, you add these 2, you put them together. Great, but the next one, we're showing a quantity unknown. Then we have the next quantity, we know it's 25 more, so we have this total amount here, which is 72, and then it's like, oh, I see that we just need this amount, which now we're reasoning through the structure going, oh, well, it makes sense to subtract at this point because we can't have more than the 72, we have to have less. Then the third one, now this one is a little bit different where we're going to have 2 rectangles because it has 2 quantities. So we're going to compare. You have the 47 amount with Maria, the brother only has the 25, and then we notice that it's looking for the difference. So with the Maria has more, so now you can see she has more, and so you can see what that difference is, and we're going to subtract. So the bar model, again, focuses on that structure, takes the weight off of what students are thinking, so their minds are not going through all of this work of trying to read the problem, understand the problem, and what a lot of teachers do, there's a lot of cute ways of doing it, and so don't be mad at me, but we're going to be, and you still can do it, circle numbers, you can underline keywords, phrases, things like that, that's great, but really what it comes down to is we teach this where each sentence, each section is what part of the bar model is this showing? Is it showing a quantity that's known, unknown? Are we talking about the total? And so then we end up creating the bar model. So we're going to model the story problem first. What does it look like? That is its own task and it's critical to offload that information. Then we can reason go, oh, this is telling me I need to add, multiply, divide, multiple operations. What am I doing? That's powerful. Then we're going to get a lot of problems correct. So when we're in the classrooms, this is how I introduce bar models. So the first thing, and now I'm basically giving a second grade, the number sets are second grade. The numbers are just going to change from whole numbers, fractions, decimals, smaller numbers, depending on your kindergarten through 6th grade. Okay, so the first, I'm going to say 47. So we're going to draw a rectangle, and we're just going to label it 47. I'll put the 47 inside the rectangle. That's the amount 47. Now in the story, what's coming next? Oh, her brother gives her 25 more. Okay, that 25. Now I want to look at the relationship. 25 compared to 47. Is it close to 47? Is it really small? Is it half the size? Well, half of 47 it was 46, it'd be 23. It's pretty close to half. So now I'm going to extend it because I'm adding on to it, but that second rectangle is only going to be half its size. That's a really important idea, and that might be something you actually have to teach beforehand. We actually have these things called quick draws. We have tons of them in our curriculum if you want to check them out. Check our website and get a lot more there. And then on the top, we just use, you can use an arc or a bar, and that represents the question mark. But again, if any of those three could be where the question mark is given depending on what the story is. And then the only other thing to really know is like when we do compare problems, we're going to have two or more, depending on how many quantities we're comparing. They all have the same starting place, and then we're going to look at their relationships. And if you're working on multi-step problems, these are so helpful. Let's take a look at how the bar model grows from kindergarten to 8th grade. So we talked a little bit about that first problem. So most of the problems for addition and subtraction are following under join, separate, joining things together, you're separating things apart, or the part whole, two parts or more, and a whole relationship. Every time it's just those two bars, those two quantities together, and the total, and there's a question mark missing. That's for all problems, whole numbers, fractions, decimals. Then there's a second one that students start to get used to. It's like, oh, but then when we're comparing things, now we're going to have two or more bars to represent the different sizes. So those, for all addition and subtraction problems, that's the relationship right there. That's the structure that you need. Then when you move into multiplication division, you might have, you're going to iterate the same size unit. So you might have 5 rectangles. So that represents I have 5 times the same thing. So I might say 5 times 12 equals 60. So here you have 5 amounts that are iterated, are copied the same. So you're building up to this area model. That's why they're all connected here. Then there's not an extra bar here, that's just the total is 60. So you just have that arc with 60 again. And then if it's a division problem, you would have been given the 60, and then you have the 5 iterations, and then you have to figure out 60 divided by 5 equals each of those units are 12. That actually goes into multi-step as well. Then you can move into ratio. You could move to percents. You could say, so the typical problems, 25% of 82 is how much? Kids, these are nightmare problems for a lot of kids in 6th grade typically. So now if you just draw a bar, that's 100%. Oh, well, I have 100% of what? 82. Oh, I could, fourth of that is 25%, so I know that's going to be about 1/4 of it. I could take 82, take half of that, 50%, I'm at 41, and then half of that, which is 20 and 5/10, or 20.5, and that's the answer. So it just gives you that visual, and you can solve it very quickly. You move into algebra. You could have an x squared, and then with it is an x and an x. So x squared plus 2x equals 35. How do you solve that? Well, now you can start looking at it just initially going, oh, there's some amount. Maybe 5 squared is 25, and then another 5 and another 5. Oh, that's 35. So now you can start looking at that relationship. So that really helps build algebraic thinking too. So this is all so helpful because in our minds, going back to what we were talking about earlier at the beginning of the talk, cognitively, you are now building that spatial awareness where you have proportion, which is really a topic that kids struggle with by 6th grade if you teach those middle grade schools. This helps build it through the curriculum, kinder through 6th grade or kinder through 8th grade. Amazing. You're also doing the dual coding. So in your head, you're like, oh, this is how the words, the context, is connecting to the visual, which then allows you to focus all your attention on the operations and the algorithms to actually solve it correctly. And the power is that it shows proportional reasoning. And that spatial reasoning is one of the best predictors of long-term success. If you want to read the research on that, we have another DMT insight on that. And just to add a couple quick things that we shouldn't do, which I see all the time. A lot of times teacher will say, we're just going to draw this out just for drawing's sake. It's like, nope, we're modeling it. So the drawing, I really like to use the term, we're going to model it to really understand what's happening. And then it forces us to go, well, then what operations are we going to use to solve it now? So model it, solve it. 2, don't put, I see this all the time, where you have 2 rectangles put together of the same size. And then teachers will put in 18 and 3. Not teachers necessarily, this is typically curriculum. If you Google things, it happens all the time. So they're seeing spatial reasoning wrong. 18 is not the same quantity as 3. And then that unknown amount. Or sometimes you see 2 bars, and then the total in another bar. It's like, no. Now you're thinking that's area model where it's all together when that's not the relationship. There shouldn't be that extra bar. We just want the an arrow, a line, an arc that shows that relationship. We've talked a lot about the do's, those are the few don'ts. So to end again, bar models are critical in getting kids to understand the structure of the math, of the story problems, to then allow for operations. And then as you do this, just like Singapore, in just a little bit of time, you're going to get kids to be so successful in mathematics. And you only need to learn about one rectangle, and that's the power of bar models. So if this got you pretty excited about teaching mathematics now, looking at story problems, two things for you. Go to mathsuccess.io to really get involved in some of our free resources, take some free courses from us, and then hopefully you'll go to our actual website, DMTInstitute.com, where we have tons of resources, both core and intervention activities from kinder through 6th grade.